Okay. So now we're going to go over the product rule and the quotient rule. Okay. So the product rule. So if you had f g prime, this would be f prime g plus f and then g prime. So let's say I was going to take the derivative with respect to x of, let's say, x to the 7, then multiplied by tangent of x. Okay. Well, I'm going to hit the x to the 7 first, so that's going to be 7 x to the 6 multiplied by tangent, put a dot right there, of x, and then plus x to the 7 times the derivative of tangent, which would be secant squared x. Okay. All right, so let's say I was going to take the derivative with respect to x of 4 to the x, and let's multiply this by, just say sine of x. So the derivative of 4 to the x would be 4 to the x times the natural log of 4, and then multiplied by sine of x, and then plus 4 to the x. Now we're going to take the derivative of sine, and that's going to be cosine of x. Let's say we're going to take the derivative with respect to x. Let's say, I don't know, let's say e to the 4x. And then multiplied by, let's say the square root of x. Okay. So that would be e to the 4x, and multiplied by 4, and multiplied by e square root of x. Okay. Now plus e to the 4x, we're going to leave that guy alone. Now we're going to take the derivative of the square root. Okay. And this can be written in a couple of ways, but if you like this way best, go with this way. Sometimes people like to write this problem as 1 over 2 root x. That just means that x to the negative 1/2 power, if you put it on bottom, it would be the square root on bottom. Okay? Let's do another example. So, let's say, do one more example of this. We're going to take derivative with respect to x of, let's say, cotangent of x, and then multiplied by x to the 5/3. All right, root of cotangent. I'm going to run out of room on this one probably. So the derivative of cotangent would be negative, now cosecant squared of x, times x to the 5 divided by 3, and then plus cotangent of x. And now we have to think of what is the derivative of x to the 5 divided by 3. So well, it's going to spit out a 5 divided by 3. And now we have to think about what is the new exponent of this thing. So it's going to be 5 over 3 minus 1. So that's 5 over 3 minus 3 divided by 3. So 5 divided by 3 minus 3 divided by 3 would be 2 divided by 3. Okay. So that's the product rule. Two things are just being multiplied together. You'll see the product rule in a new way later on, because the product rule actually leads to integration by parts, which is going to be one of the first techniques of integration you learn in calculus too, how to integrate things that are being multiplied together. So when you do integrals, also, if things are multiplied by together, you can't do them individually. You have to follow a rule. Okay. So that's the product rule. And then we have quotient rule. All right. Okay, so if you have things that are going to be divided. Right? So, what is this? This is f prime g minus f g prime, and then divided by g squared. Now, some people remember this rule as there's some saying that I think they teach in high school that's like high D, low, low D, high. I don't know what it is. I'm going to show you how to derive this in the next video when we get to the. Yeah, no, we'll have to go to the chain rule with that. So once we get to the chain rule, I'll derive this formula for y'all. And so I actually just remember this through the derivation and not some little saying. Okay? So let's see this in action. So let's say I was going to take the derivative with respect to x of, let's say, cosine of x divided by 6 to the x. Okay. So the derivative of cosine is negative sine. And we're going to leave the 6 to the x alone on that one. And minus cosine, so we'll leave the top out on that one. And then this would be 6 to the x times the natural log of 6. And this would be divided by 6 to the x squared. Okay. So let's say I was going to take the derivative with respect to x of x to the 123 divided by secant of x. I'm probably going to run it for on this one. Okay. So that's going to spit out a 123 x to the. I'm going to run out of room on this. I'm going to move it down here. So that's going to equal 123. Now 123 minus 1 would be 122. And then that's going to be multiplied by secant of x. So that's f prime g. Now minus f, and g prime derivative secant is secant x tangent x okay, and all of this is going to be divided by secant of x squared. And I think we can put all this onto one video. So that's the product rule, the quotient rule, and let's put the chain rule also on this video. So I'm going to write this in a slightly different way. Let's say f of g of x is going to equal f now prime of g of x, then multiplied by g prime let's say I wanted to take the derivative with respect to x of, let's say, e to the x to the fourth. Okay? Well, the derivative of e is just e. So this is going to be, well, e x to the fourth, and then multiplied by the derivative of x to the fourth, which would be 4x cubed. Let's say we want to take the derivative with respect to x of, let's say, sine of x to the seventh. Derivative of sine is going to be cosine. Gotta leave that guy alone on the inside. And then we're going to take the derivative of x to the 7, which would be 7x to the 6th. Here's one that throws people off some. So let's say I was going to take the derivative with respect to x of secant of, let's say, 5 to x. Okay, now when you do this one, you just need to remember that the derivative of secant is secant tangent. You need to keep that 5 to the x in both the secant and the tangent. So this would equal secant of 5 to the x tangent of 5 to the x, and then multiplied by 5 to the x times the natural log of 5. Okay, now in all of these, it's a little bit obvious which guy is on the inside because, well, it's surrounded by parentheses. Okay. There are cases where it's not as obvious what's going on inside of the problem. Okay? So let's say I was going to take the derivative with respect to x of sine squared of x. See, it's not exactly obvious which guy is trapped within the parentheses. But if you want to think about this in a slightly different way, that's really sine of x squared if you move that squared to the outside. Okay? So the first thing we're taking the derivative of is the square. So since we're taking the derivative of the square, that's going to drop down to 2. I mean, it's going to spit out a 2, drop it down to 1. So that's going to be 2 sine of x. And then we have to consider what is the derivative of sine, and the derivative of sine is cosine of x. So similarly, if we're going to take the derivative with respect to x of, let's say, the square root of, let's say, tangent of x. Okay. So the first thing we're going to take the derivative of is the square root. Okay. So that's going to come out when we take the derivative of the square root. That's going to spit out a 1/2 into that spot right there. Now tangent of x to be negative 1/2, and then multiplied by the derivative of tangent of x, which is secant squared of x. Okay, so that's the product rule, the quotient rule, chain rule. let's consider these problems. What if they're nested within each other? I mean, what if you have like three things that are nested? So if we said, okay, what would be the derivative with respect to x of sine of x? Ooh. Well, we're going to do this. What we're going to do is we're going to take the derivative of this guy first. Okay? So if I take the derivative of that guy, that's going to be cosine of sine of x. All right? Now I'm going to take the derivative of this guy right here. So the derivative of sine is cosine of sine of x. Times the derivative of this guy, which is going to be cosine of x. So you can see by doing this problem that the first component that I'm hitting is this sign right here. I'm saying, all right, well, the derivative of this guy is going to be cosine, okay? And I'm leaving everything on the interior alone. And then I'm saying, okay, well, now I need to take the derivative of this thing right here. So I'm going to hit this guy. All right, okay, so the derivative of that guy is going to be cosine. Then the very last one said, all right, now I'm going to hit the guy that's on the very inside. So that's where I'm going to get that cosine of x right there. Similarly, let's say we took the derivative with respect to x of e to the e to the e to the x. Okay. Well, I'm going to hit the first e first. All right, now I'm going to go to this guy. Okay. Let's ask ourselves, oh, what if we had three things being multiplied together? Instead of just the chain rule. Let's just say, what if we had three things being multiplied by together? How do we extend the product rule? Actually, I don't want to go there right now. Why don't we prove the quotient rule right now? So, consider a problem like this, a generic problem. So, 1 divided by g of x, just an arbitrary g of x, any function. Okay. As long as it's not 0, because you can't have it divided by 0. So what is this really? This is some g of x to the -1 power. Okay. So if we have g of x to the -1 power, we're really taking, you kind of want to think about this as taking the derivative of 1 divided by x. What is the derivative of 1 divided by x? That would be, well, the derivative of x to the -1, so it would be -1 divided by x squared. Okay? So if I think about this problem with an arbitrary g of x, this would become -1 divided by, I'll write it like this, g of x squared, and then by the chain rule, we're going to have to multiply by g prime of x. So what does this have to do with the quotient rule? Well, the quotient rule is actually going to be derived from a combination of the product rule and the chain rule. This is how I actually remember which spot goes where. So if I was going to say, okay, I know that this is true. And so if I was going to try to take the derivative of f of x divided by g of x, that's another way I consider this problem. Okay, what about f of x times 1 divided by g of x. Why don't I try doing the product rule on this thing right here? So, what is this going to come out to? That would be f prime of x, and then multiplied by 1 divided by g of x, then plus f of x, so that's f prime g, well, let's say it that way. Okay, so now we need to take the derivative of 1 divided by g of x. So that's going to be negative 1 divided by g of x squared multiplied by g prime of x. Okay. Well, to get a common denominator on this thing, I would say, why don't I multiply this guy by g of x divided by g of x? So this would be f prime of x times g of x divided by g of x squared, and then minus f of x times g prime of x divided by g of x squared. Okay, now we have a common denominator on this thing, and so that actually leads to the formula of f prime g minus f g prime divided by g squared. So the way I memorize this formula is like, okay, which one has the minus on it? Well, the g is on bottom. So when I take the derivative of the 1 divided by g, I'm going to get negative 1 over g squared. And so that's where this negative 1 is actually coming into the problem. And that's where that g prime is coming from as well. So this is normally how I think of the quotient rule. Okay. Well, to cap out this video, why don't we just do one other problem? Let's take the derivative of tangent and really show that it's secant squared. So, as long as we're talking about the quotient rule. So, the derivative with respect to x of, say, sine of x divided by cosine of x. Okay. So we're going to apply the quotient rule to, remember, the tangent is just sine divided by cosine, so let's apply the quotient rule to this problem right here to prove that the derivative of tangent really is secant squared. All right. Okay. So f prime, that's the guy on top right there, sine, derivative of sine is going to be cosine of x times cosine of x. All right, f prime g minus f sine of x times the derivative of cosine, which is negative sine of x. I'll rewrite this. Now divided by cosine of x squared. I'll make it look better on the next line. So this would become now cosine squared of x. Okay, sine of x and negative sine of x, well, the negatives will cancel each other out. So that's going to be plus sine squared of x. Now divided by cosine squared of x. All right, now this is when you need to remember your trigonometric identities. Okay? Mainly, that sine squared plus cosine squared equals 1. There's actually another way to think about this problem. If I broke this into a fraction, cosine squared divided by cosine squared would be 1. Sine squared divided by cosine squared would be tangent squared. This is a little bit trickier, but 1 plus tangent squared is secant squared. But if you just know that sine squared plus cosine squared equals 1, this is going to come out to be 1 divided by cosine squared of x which will equal secant squared of x.